Alright, in lesson 6, we're just going to do a little bit of work. We're just going to do this opening exercise to have a refresher on long division. Okay, so it says use long division to determine the decimal expansion of 54 over 20. So all you're going to do is take the numerator, which is the top number, and divide it by the denominator, which is the bottom number. 20 goes into 50 two times. 2 times 20 is 40. You multiply here and you subtract. 4, 1. You add a 0, you bring it down. 20 goes into 40. Oh, when you add the 0, you have to put a decimal point up there. Sorry. So now 20 goes into 40 7 times. 7 times 0 is 0. 7 times 2 is 14. We subtract and get 0. So the answer, 54 over 20 equals 2.7. Okay? Same thing here, numerator divided by denominator. Okay, 8 does not go into 7, so you put a 0, a decimal, and a 0. 8 goes into 7 8 times, 70 8 times. 8 times 8 is 64. We get 6. We add a 0, we bring it down. 8 goes into 60 7 times. 7 times 8 is 56. We subtract, we get a 0, we get 4, we put a 0, we bring it down. 8 goes into 45 times. 5 times 8 is 40, we subtract it. So 7 eighths equals 0.875. On C, okay, use long division again. So 8 divided by 9. 9 does not go into 8, so 0 decimal 0. 9 goes into 87 times, 8 times, sorry, 8 times. 8 times 9 is 72. We subtract, we get 8 again. 0, bring it down. So what's happening is we're going to get the same thing. 9 goes into 88 times. We subtract 72, we get 8. So what that means is that this is going to be repeating. It's going to go on forever. So 8 over 9 equals 0.8 repeated. So that's the only number that repeats is the 8. And that's called a repeating bar. We're going to do the same thing down here on D. Okay, 22 divided by 7. 7 goes into 22 3 times. We put a 3 times 7 is 21. We subtract and we get 1. We put a decimal and add a 0. We bring it down. 7 goes into 10 one time. 1 times 7 is 7. We subtract and get 3, add a 0, bring it down. 7 goes into 34 times. 4 times 7 is 28. We subtract and get a 2. 0, bring it down. 7 goes into 21 2 times. 7 times 2 is 14. We subtract and get a 6. 0, bring it down. I'm not seeing a pattern yet, and it's not ending yet. So I need to keep going until I see a pattern or until it ends. So 7 goes into 68 times. 8 times 7 is 56. We subtract and get a 4. 0, bring it down. 7 goes into 40. Whew. 5 times. 5 times 7 is 35. We subtract and get 5. 0, 0. 7 goes into 50. 7 times. 7 times 7 is 49. We get 1. And what happens is this one is going to start over because we had a 1 up here. So this whole thing, 1, 4, 2, 8, 5, 7, that's going to repeat. The whole, all of 6 of those numbers. So 22 over 7 equals 3.14287, all repeating. Now, if you notice, these two ended, like they terminated, they didn't go on forever, and these two down here go on forever. And that's called something special in the math world, and I want you to create this chart and write this down, okay? Finite decimals are like A and B. They end, okay? So could say 54 over 20, which is 2.7. You could say 7/8 or 3.68. Any number that has a final ending point is what this would be. Every finite decimal, okay, can be written as a fraction. That has a decimal expansion that ends. Okay, so this would be any number that has a decimal expansion that ends. And it can be a fraction, but the decimal expansion has to end. It could be a square root, but the decimal expansion has to end. It could be several different things. Infinite decimals, examples would be pi. Pi goes on forever and ever and ever. Decimal or fractions with a denominator of 9, so like 4/9, that doesn't end because the 4 keeps on repeating. We could do the 22 over 7. Okay, so this is can be written as a fraction, but does not have a decimal expansion that ends. It goes on forever. Okay, that's what infinite decimals are. And so if we go back to this, okay, we can say, okay, this one ended, so this is finite. This one ended, finite. This one did not end, so it's infinite. And this one did not end, so it's infinite. Okay? So that's all we're going to do of 6. So now let's jump over to page S32 right here. And we're going to go through 7. Okay, so in the opening exercise, it wants you to write the expanded form of the decimal using powers of 10. So, you've done this expanded form using powers of 10 in math. So what we're going to do is this would be 0.3765 equals 3 over 10, because that's in the tens place, plus 7 over 100, because that's in the hundreds place, plus 6 over 1,000, because that's in the thousands place, plus 5 over 10,000. And we can rewrite that, and I didn't do powers of 10, so I'm going to rewrite this. So 3 over 10 plus 7 over 10 to the second plus 6 over 10 to the third plus 5 over 10 to the fourth. Okay? Write the expanded form of the decimal 0.3 repeated, because there's dots right here, so that means it's repeated, using powers of 10. So 0.3333 equals 3 over 10 plus 3 over 10 to the second plus 3 over 10 to the third plus 3 over 10 to the fourth plus 3 over 10 to the fifth, and that would just go on and on and on and on forever because this is repeating. Okay? We're going to come back to wondering about the value of 9 repeated. Some people say that it has a value of 1. Some people disagree. I want you to write what you think here. Do you think 0.9999999 forever and ever and ever is 1, or do you think it is something else? Take a little second and write down your answer to see. Okay, so on example 1, it shows it on the number line below. Okay, and I want to talk to you about this real quick. If we put this as a power of 10, 0.253 would be 2 over 10 plus 2 over 10 to the second, plus, or sorry, 5. That would be 5. Plus 3 over 10 to the third. Okay? So, here's 2 over 10. Okay? But it's more than that. We have these two. So we're going to open that up. And then it would be between 0.2 and 0.3 where we get the 5. 2.5 would be right here. And then we would open it up again between 0.25 and 0.26. And then put our, so if you look at this, between 0 and 1, okay, this is where 0.2 would be, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because it's to a power of 10. So there would be 0.2. Then I need to do the 5 over 10 to the second, so I would expand it again. And I'd get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'd go over to the fifth one. Okay, so it'd be between here and here because the 3 is going to make it a little bit bigger. So then we'd expand it again to be between 0.25 and 0.26. And we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal pieces. And then we'd go over to 3 for the 3 over 10 to the third. And you want to make sure that it's divided into 10 equal parts each time. Okay? So, now we're going to go on to example 2. We're going to show you another one. A repeating decimal. So, 5, 6 equals 0.83 repeated. The 3 is repeating. So if we were to write this out, it would be like 8 over 10 plus 3 over 10 to the second plus 3 over 10 to the third plus 3 over 10 to the fourth plus 3 over 10 to the fifth plus, and it would go on and on and on forever. Okay, so for this first one, 0 to 1, I'm going to make 10 marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I know it's going to be greater than 8, but it will not go over 9, so that's why we get this, 0.8 to 0.9. And then we have our decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 equal parts. And then because of the 3, I'm going to go over 1, 2, 3. So now, because it's not going to go over 8.84, we're going to open that up. And between 0.83 and 0.84, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. And because we're at a 3, we're going to go 3 over 1, 2, 3. And then it's going to be between 0.833 and 0.834, again, over 3. And it's just going to keep going like that, infinitely on. Okay? So now we're going to flip over and write the expanded form of decimal 0.125 using power of 10. So 0.125 equals 1 over 10 plus 2 over 10 to the second, it's the second one after the decimal, plus 5 over 10 to the third, it's the third one after the decimal. Show on the number line the placement of the decimal 0.15. So now we're just going to do this here. So we're going to go to here, 0.1, and we're going to open it up like this, if I can draw. So 0.1 to 0.2. Okay? And it's, our next one is 2, so I go over 2 to here. So 0.12, and that's going to go here to the first one. And then 0.13 will go here. And then it's 5, so I'm going to go over 1, 2, 3, 4, 5, 0.125. 2. Write the expanded form of the decimal 0.3875. That equals 3 over 10 plus 8 over 10 to the second, because it's the second one, plus 7 over 10 to the third, it's the third, plus 5 over 10 to the fourth. So because it goes to the fourth, we're going to have a few more, we're going to have one more line, okay? So to the 3, so 1, 2, 3, 0.3, that's this one. So it goes here, 0.3 to 0.4. And then we're going to do the 8. So 1, 2, 3, 4, 5, 6, 7, 8. 0.38. So 0.38. We're going to take this one, 0.39. And then we're going to do the 7. 1, 2, 3, 4, 5, 6, 7. 0.387. And then 0.388. Okay. And then we're going to do the last one, the 5. 1, 2, 3, 4, 5. 0.3875. Write the expanded form of the decimal 0.7 repeated with powers of 10. So 0.7777 repeated, and it gives us 1, 2, 3, 4, 5. So we'll go to 7 over 10 plus 7 over 10 to the second plus 7 over 10 to the third plus 7 over 10 to the fifth plus 7 over 10 to the sixth, that would be fourth, this would be fifth, plus dot 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 dot. It would go on. So then down here we're going to put it on the number line. So the first one is 7. So in between 0 and 1, 1, 2, 3, 4, 5, 6, 7. We pull it out here, 0.7. So it's between 0.7 and 0.8. We're going to go to the next 7. 1, 2, 3, 4, 5, 6, 7. 0.77 goes here. And 0.78 goes here. And again another 7. 1, 2, 3, 4, 5, 6, 7. 0.777. And 0.777 between 0.7 8. 1, 2, 3, 4, 5, 6, 7. this would be 0.123. 1, 2, 3, 4, 5, 6, 7. And that would continue forever and ever and ever. Okay. Whew. Let's go over to 4 to look at this one. Okay. 0.45 expanded. So this would be 4 over 10 plus 5 over 10 to the second plus, because the 4 repeats, 4 over 10 to the third, and then the 5 over 10 to the fourth, plus 4 over 10 to the fifth, plus 5 over 10 to the sixth, plus, and it would just go on forever like that. So now we're going to put that on the number line. So 0.4 is what we're going to do first. So 0.1, 0.2, 0.3, 0.4. So it's between 0.4 and 0.5. And then we're going to do the, so 0.41, 0.42, 0.43, 0.44, 0.45. This will be 0.46. So now we're going to go 0.451, 0.452, 0.453, 0.454, because the next one is 4. So this would 0.454. This would be 0.455. So then it would be 4.545. So 4.54, 4.541, 4.542, 4.543, 4.544, 4.545. .4545. This will be 4.546. And then we're going to repeat again to 4. So 4.545, 4.5451, 4.5452, 4.5453, 4.5454. 0.45454. Okay. Then we're down here on 5. It wants us to order them from least to greatest. Okay. So this is 1, 2, 1, 2, 1, 2. Okay. And what we're going to do is we're going to put the whole numbers, we're going to write it, the whole numbers first. So we're going to put these with the, using the powers of 10, the expanded form. So 2.121212 equals 2 plus, the whole number stays there, 1 over 10 plus 2 over 10 to the second plus 1 over 10 to the third. I might run out of room. Plus 2 over 10 to the fourth plus 1 over 10 to the fifth. Oh, I did run out of room. Plus 1 over, or 2 over 10 to the sixth. So this stops at the sixth. I didn't have enough room. 2.1 equals 2 plus 1 over 10. 2.2 equals 2 plus 2 over 1 over 10. And this is 2.12 equal repeated. So equals 2 plus 1 over 10 plus 2 over 10 to the second plus 1 over 10 to the third plus 1 or 2 over 10 to the fourth plus 1 over 10 to the fifth plus, and it goes on forever. So if we look at the fractions, because they have the same decimal, okay, we should be able to put them in order, or the same decimal. If we look at the fractions, they have the same denominator. So the 2's kind of cancel each other out. Okay, so then the next lowest one would be 2.1. This has 2 over 10. This has a 1 over 10 plus something else. So this would go next, right here. 2.121212. Then we would have 2, and this is 2, and this is 1. So 2.12 repeated. And then we would end with the 2.2. Okay, and I would explain this by saying using the denominators of the expanded form with powers of 10, I compared the fractions numerators.